Hi, here's a short example for mini lecture 7, which is really about independence and combining probabilities together. It's a question from the problem sheets that you've been given for this week, and it's about taking all this stuff about probability and showing how an engineering decision can be made with it. So this is a case where we have a circuit and it contains 3 automatic switches, and we want them all to work within a given time interval, and well, you have to put a probability on how confident you want to be that they're all going to work. So we've decided that 95% is what's acceptable, so we need to be 95% confident that within a given time interval all of those switches are going to work. But when you come to buy a switch, you look at its specification and it gives you some indication of what its likelihood of failure is, but it doesn't tell you what it is for the case of 3 together where none of them fail in that time period. It will just tell you about the switch on its own. So we need to convert one to the other. So what we want to find is the probability of failure per time interval for a single switch that will give rise to the system that we actually want. Okay. So we need to define our terms. So the events are F is fail or NF is not fail. And we can define the probability of it failing within a time period. This is a single switch failing within a time period as X. And therefore the probability of it not failing, that's the complement of it failing, that's equal to 1 minus X. And now the system that we've got, well, that has 3 switches in it, and we want to know that the probability of them not failing will be 95%. So here we can convert the probability of none of the 3 switches failing, so that's switch 1 not failing and switch 2 not failing and switch 3 not failing. We can convert them into this expression where we've multiplied the probabilities by each other. When can we do that? Why can we do that? Well, we can do that by assuming independence. So if these switches fail independently, then that's true. Now that's an important assumption. It may or may not be true. For example, switches might be manufactured in batches, and if there's a fault with how a certain batch was manufactured, maybe all of those switches are likely to fail more quickly than they are normally. So there's some assumptions in there which you need to be aware of. If you assume independence, then you can treat it like this. And then of course we've designated a parameter to that, and so that's 1 minus X to the power 3. So that's the probability of them of none of them failing within that time period. And we need that to be greater or equal to 0.95, and so now we can solve that equation for X, taking the cube root, and then that tells us that X needs to be less than or equal to 1 minus the cube root of 0.9, and so that means X needs to be less than or equal to 0.017. So then if you're buying a switch, it needs to say that within that given time period its probability of failing is less than 1.7%.